Assalamualaikum warahmatullahi wabarakatuh. My name is Firgi and today and in this video I will talk and discussion about alternating current and three-phase theory. So the discussion about this video, the first one, the definition of alternating current, the second one, circuit of alternating current, and the third one, formula of alternating current, and the fourth, the definition of three-phase system, and the last one, the connection of three-phase system. So the first one is the definition of alternating current. What is alternating current? Alter the alternating current is an electric current and voltage change based on time and flow in both directions. So the value of the current and voltage in this in AC or alternating currents, it will change based on time. Like we can see in the graph, the value of voltage will change and the direction will change too based on the time. The next one, the circuit of alternating current. Number one, resistor circuits. Resistor circuits, when connected to an alternating current, will result in a decrease in the electric potential in the circuit, or in the other words, as a limiter of the incoming currents. So we can see there's a circuit of the resistor circuits. We can see that the power supply is AC or alternating currents, and there's a resistor, and there's a VR or the voltage of resistors. So the next is the graph of the resistor circuits. When we can, as we can see, the current and voltage has a different value and the directions change too. The next one is inductor circuits. An inductor also has a resistance value, which is commonly called inductive reactance, when an alternating current flows through it. The value of the resistance of this conductor depends on the angular frequency of the alternating currents. So, as we can see again, there is a circuit and the graph of these inductor circuits. The next one, the capacitor circuits. The capacitor circuits is a unique circuit where the circuits can store electrical energy temporarily. So, the capacitor, when energized and alternating currents, will cause apparent resistance, or commonly called capacitive resistance. The value of capacitive reactance depends on the capacitance of the capacitor and the corner frequency. As you can see, there's a capacitor named C, and there's a power supply named V, and there's a graph of the capacitor circuits. And the capacitor can store the electrical energy temporarily. So if we cut the power supply and we uh, and we make it to on the lamp will be active temporarily, and then it will off or down again. And the formula of alternating currents, the first one is general equation, V equal V max sin omega t. And the next one, voltage and current through resistors, ER equal EM sin omega t, VR equal Vm sin omega t, and the voltage and current through inductor, EL equal EM sin omega t uh, minus half P, VL equal Vm sin omega t, and the voltage and current through capacitor, IC IC equal Im sin omega t plus half p, and Vc equal Vm sin omega t. And the next one is the definition of three-phase system. What is three-phase system? Three-phase system is a system that uses three cable for generation, transmission, and distribution. The three-phase system induces a generator that provides a three-phase voltage of the same magnitude and frequency. It provides uninterrupted power, that is, if one phase of the system is disconnected, then the remaining two phases of the system continue to supply power. The sum of the current in one phase is equal to the sum of the current in the other two phases of systems. As you can see, this is a graphic of the three phase when the value of a phase is equal. So there is no difference between phase 1, phase 2, and phase 3. The difference between other phase is the degree or the phase itself. So like we can see the phase 1 and the phase 2, there's a different 120 degree, and the phase 2 between phase 2 and phase 3, there's a different 120 degree too. Okay, the next one is connection of the three-phase system. The first one is the star connections. The star connections require four wires consisting of three-phase conductor and one neutral conductor. This type of connection is mainly used for long-distance transmission because it has a neutral point. The neutral point passes an unbalanced current. The star connection connected to a three-phase system provides two different voltage, namely 230 volt and 440 volt. The voltage between the single phase and the neutral is 230 volts, and the voltage between the two phases is equal to 440 volts, as we can see in the picture in the right. And there is a three-phase star-connected system, and when the load 1's connected to 230 volt and load 2 connected to 440 volts. And the next one, the delta connection. The delta connection has three wires and no neutral points. The delta connection is shown in the figure below. The delta connection line voltage is equal to the phase voltage. So it means L1, L2, and L3 have a voltage. The voltage of the three line is equal. So there is no different voltage between this line. So that's all from me. Sorry for my mistakes. Uh, that's all. Assalamualaikum warahmatullahi wabarakatuh.